Okay, dear friends, we are going to have the first exercise that is 1A. It will be like a revision, the thing. I'll just go for sharing the screen. Okay, I hope you can see the screen now. Yeah. So today we are going to see about the exploratory, how we are going to make as it is the revision. Okay, we will do as you all did the data science in the previous lab. So let it be like a refreshing session, that is 1A. So we will see it is like exploratory data analysis, how we will do with the data set. Okay, so that is it is like a process of examining and visualizing the data to uncover the patterns and how much we are going to make the relationships between the attributes in the data set and anomalies and how and also the second part we are going to see about what are the data processing pre-processing we are going to do that is cleaning and ready for processing. So today we will discuss about the exploratory data analysis. In the next video I will post about how the various data pre-processing that can be done. Both these two concepts will become the exercise one for your lab exercise. So let us see about the exploratory data analysis. Okay. First, initially, as you know, for importing the required libraries for the exploratory data analysis, for that we have to import the pandas, in order to represent the data in the form of the data frames and import NumPy for the numerical data, and then Seaborn and Matplotlib is used for visualization process. Okay, to have this process to be done, we have to go for these libraries to be imported. Okay, for that first we have to import all these, and then we have to go for the next set of thing. Okay, so first we are just reading the data set. So we are having the data set Toyota.csv. It talks about the features of the car. In which, okay, the data types you can see when I'm just giving NA values, that is, if I'm giving the question mark, and I can be replaced if any null values which is there, I can replace it by NaN. Okay, for that I'm giving this particular command, okay, and across the different columns. So when I just display the head of five, that means the first five rows, if I want to display, then I have to give df, that is the data frame, okay, because we have given the data frame name as df. So df dot head of five. So first five rows it will be displayed. Okay, so we are getting the result here. You can see there is no null. So here it may be question mark in the data set. So it is replaced by NaN because we have given this particular command in the syntax, right? So this is how we can just fill it so that there will be no null values, then we cannot do the analytics. Okay, so for that is the first thing we have to do. Okay, whenever we are just accessing the information or do any manipulation in the data in the data set. And then when I'm just giving describe, okay, that is the summary of the data set. Okay, so when I'm giving df dot describe, it will give you the complete summary, that is count. That means the particular column price, age, kilometer, okay, HP, med color, automatic, CC, weight, all are numerical values. Okay, so fuel type is another column is there, but that is not taking because this describe will take only the numerical values. Okay, it will take only the numerical values and it will produce the result out of it. So count, it takes the count. That means what? How many okay, non-null values which is present. Got it? So that is how it takes the for the price. So 1436 non-null numerical value which is present. For age, 1336 non-null values it is taking. Got my point? So kilometer, so non-null values like for different cars. It is giving, okay, so that is the thing for count. and the mean. So finding the average of all the prices of different cars. Okay, so across the column, it takes and it gives the result out of it. And then coming to STD, that is standard deviation. Okay, so you know the formula for the standard deviation for this particular column price, it gives the result. And then minimum, the minimum value of that particular column price, it shows. That is also showing in the summary. That is 4350, right? And then what about this 2557? Okay, this is the lower bound and this is the median value and this is the upper bound 75%. Got it? And then maximum we are taking. That means what? 25 quarter versatile. That means what actually? So that means 25% it will take the value from the data set, and in that the maximum is 8490, and then takes randomly 50% of the things, and then it takes the maximum value is 9900. Got it? And then 75%. So why we are making it means sometimes the data set, the growth, if we want to show year wise. So first 25% of the data set when we take, we can say that first quarter, how much the growth, and then 50% how much the growth, and then 75% what is the growth, and then the maximum, the current what it reached. Got it? So this is how, if you want to do the analytic to know the summary, we are not taking the complete data set and give the result. But when we took the summary, we can take the first 25% of the data will be taken and it gives the maximum value out of it. Got it? So this will give the user to know more about the information. These are the things we have seen already. Okay, in the previous semester itself, just as I told you, we are refreshing the topic, right? And then here data frame dot tail of 5 means the last 5 rows in the data set will be displayed. So here also you can see that all the data which having the null, which is replaced by nan, because we have already given that particular command, right? So here also it is filled, and you can look at it. Wherever the null values, it is filled with nan. Okay, so this is how I can display the last 5 values. If I want to see the first 5 value, end of 5, similarly for tail of 5, to show the last set of rows to display, right? And then coming to the df dot columns. Okay, that means only what are the columns which is present. That is the attribute name. So price, age, kilometer, fuel type, HP, med color, okay, automatic, CC, dose, weight, around 10 different attributes which are there. Okay, so that only which are giving it as index, and the D type, that is object. That means what? Object means it can have number value and also it can have character value. So that's why we are putting this object as the data type. We will get it when we just put the columns. Okay, so that also it is displaying when we want to know the columns. If we want to display the data type of all that thing, and also what are all the different columns or attributes which is present, I have to give the command as df, that is data frame dot columns. And if I'm giving data frame dot size, that means what? Row into column. That means what? How many rows are there? 1, 4, 3, 6 rows are there, and 10 different columns, 10 different attributes. So multiplying it, I'm getting the value as 14360. If I put df dot shape, I can find out how many rows and how many columns. So 1436 rows are there and 10 columns are here. Okay. So depend upon the query, what it is asked, you have to just give the command. Just to refresh this, I have given all this. Okay, and then I'll give the exercise for you so that you can just work it out, and you can just put all these commands and you can check it out, right, for your data set as well. And then coming to the next, that is df dot g types. I want to know individually for each and every column. Okay, so each and every column or different, each and every attributes I want to know. Simply I put columns means overall, it makes it as object. But if I'm giving D types means each and every column, what is the data type I can find? This is integer, this is float, okay, and then fuel type is object, because here sometimes it will have numerical value and also it will have the character value. So let us check, okay, so that time you will understand about fuel type, why it is object. And then HP, that is float, okay, and then med color, again float, okay, and then okay, automatic or not, okay, that is integer. Okay, we are converting it into an integer. CC, integer, okay, doors, object, and then okay, wait. Sometimes object means 4. If I'm giving FOUR, it may be given like this, okay. And then weight is in 64, okay, integer. So this is how I can just overall data type, I can give it as an object, but individually I can also get the data type. So what I have to give data frame, that is df dot just d type. Okay, then I can get individual thing. Okay, and coming to the next, what is the memory consumption? Okay, so in bytes, if I want to know, I can just give df dot memory usage. I can just find out index, price, age, all the different attributes. I can have the value in bytes. Okay, so how much memory consumption it made, it will give the result out of it. Okay, so here everything we have made it into NaN, okay, and no null values here. So that's why all the columns which is taking, so maximum number of rows we have seen, right? 1, 4, 3, 6. So each and every column takes the, okay, how many things in the table? 1, 4, 3, 6. So that is calculating the memory bytes. Okay, memory in bytes, that is 11,488 bytes. Okay, so this is how I can use the memory usage for different attributes. Okay, and coming to the next, that is the NDIM. So if we want to know the dimensions, how many things, so I can say 2 dimensions. Okay, 2 dimensions only, row cross column. Okay, so I can say it is 2. Okay, so likewise I can find out the number of dimensions by giving NDIM. Okay, and the next I can just give like okay, across the column. Okay, I can give that is a call equal to 0, that is index call equal to 0, and then NA values, that is giving the question mark, okay, and double question. Okay, I can give like this to fill the okay thing with the filling all this with the okay nan. Already we did it. Okay, if I want to copy it, I have to just give dot copy. Okay, if I'm giving just a copy of it, then I have to give the another file name with the cars underscore data to. Okay, and all these cars data, okay, this file, okay, data will be copied into a new data frame, that is cars data 2. Got it? So that is also I can be done. And hereafter, if I'm using cars underscore data 2, here all the data will be present. Okay, so this is how I can copy the information into the another data set, right? And then this is like 2 or more, okay, categorical thing, that is statistical method used to analyze, okay, the relationship between the 2 or more categorical thing. For example, if I am giving a index equal to cars data fuel type, okay, and then comma columns equal to count, that means what? Across the column you will get the count. Okay, and all these that is a fuel type, it will be arranged in the row format. Got my point? So that is how I am getting it out, and then I am asking it to find the count. Got it? So what it will come, CNG, diesel, and petrol. These are all the 3 fuel types, and all these fuel types, this will be categorized one after another. That is CNG, diesel, and petrol, and it will give the count of it. So how many CNG cars which is there, and then how many diesel cars which is there, and how many petrol cars which is there. Likewise, it is going to count it, calculate sum of it, and then give the result out of it. Okay, so count I have to column I have to give, and this fuel type I have to give it in the rows. That is the thing I am giving, like index, in which I have to give this is the cars data 2 is the data frame in which I am giving fuel type, and then here I am giving a count, okay, columns count, that is the second thing, and then I am giving, okay, so here it will be arranged. Okay, the count will be arranged in column and it gives the result out of it. Got it? So this is how if I make. So again, I can also make CNG, diesel, and petrol in different columns. So how to give? So that is the thing here I can give. Columns equal to cars data 2 of fuel type. If I'm giving like this means I can get CNG and then diesel and petrol, everything it will be like here, in which I want to find only the automatic. In the previous thing, I'm finding the count of the different thing. If I'm giving count itself, all that thing, it will given the count value. But here I'm just checking it out. Which are all the things have petrol and automatic. CNG have petrol and automatic? No. Okay, so then we will have zero. Okay, and then diesel have any automatic? No. So it is giving zero. And then here I can have a petrol only. I can have, okay, both automatic and manual. Okay, so this is manual value, that is 15,144. These are all the things for CNG and diesel and petrol. But only for petrol, I have automatic. So that's why for automatic, these values are zeros, and only for petrol, I'm getting the value out of it. Got it? So this is arranged in the format of okay, all the fuel type, which is arranged as columns. Okay, the previous thing we have seen it as rows, and here I'm making it as columns. Okay, so this is how I can rearrange and I can display the result out of it. Okay, and the next we have to see about the correlation. Okay, we have seen about the correlation. That means what? Each and every attributes what relationship between one another. Okay, I want to know it. So for example, price and price, age and age, kilometer and kilometer, HP and HP, mid color and mid color, automatic and automatic, CC and CC, weight and weight. This is how whenever I compare the relationship, both will be the same. That's why in diagonal, everything it will be 1. Okay, and then if it is closer to 0 means, okay, so that is less correlation. Okay, and then if it is closer to 1 means it has more correlation, that is more relative to one another. Got my point? So that is how I'm just making the relationship between the two particular labels, okay, or two particular attributes. Okay, so then if I'm putting for age and price, both will be the same. Okay, like age and price means I'm getting the value as minus 878407. Similarly, age and price, here also I'm getting the same value. Got my point? So one half diagonal will give the complete result. The other diagonal will be like a mirror of it whenever we see the correlation. And the diagonal thing always it will be 1. Okay, because price and price means there will be no difference. So no correlation. So we have to put it as completely as 1 only. Okay, so we cannot make reduce less than 1 or greater than 1, because it is like the same values. Okay, so that is how I can just put the correlation between the different attributes and I can display the value. Okay, for that I have to just give, okay, just I have to give exclude equal to object. That means what? I have to remove all the categorical value. Only the numerical value I have to take, and then I have to give the correlation. So for that I have to give car matrix. Okay, that is a correlation matrix. I have to print it. Okay, so numerical data, that is the data frame dot car. That is the correlation function. Got it? So that will be stored it into the variable, and then I'm printing the variable. When I'm printing it, I will get the clear table which reflects the correlation, that is the relationship between the different attributes. Okay, so this is how I can do the I can find the relationship between the different attributes in the data set, right? And then coming to the next, I have to drop all the null values. Okay, so if I want to make like drop NA axis equal to 0. Okay, so that means across the rows. Okay, wherever the null values, it have to be removed. Got it? So if I make like this means, if I want to display the head of 5 means the second row we have seen in the data set, right? Then the second row has null, so that particular row is deleted. Okay, so that is the meaning of a drop ending. Okay, so that particular rows having null, which is drop. Okay, so that is the meaning of it. So when I display the head of 5 means the first 5 rows will be displayed, that in which the 2 is not there, and continues. Okay, the process continues. So that is how I can remove the null, okay, from the complete rows. Okay, for that I have to use this particular syntax. Okay, and coming to the next, till now we have seen about some of the commands and how to access the data, and some okay, how to find the summary and so many, okay, commands we have seen, and okay, related to the exploratory data analysis. And now we will see about some of the things that talks in terms of the visualization. Okay, so first the scatter plot. As you know, the scatter plot means it is also finding between the two numerical variables only. So here I am going to find the relationship between the price and the age. As you know, the cost, the price of the, okay, the age increases of the car, okay, automatically the price also will be decreased. Okay, so that's why you can see okay, for 80, okay, age, that is month, you can see the great drop of cost, okay, when we compare to the initial stage. This, you know, the normal, right? So you know this normal thing, because initially it will be less, because it is, the car is not tested much. Once the engine set, after that we find the mileage, then the cost of the price increases. What my point? So that's why initially it is delayed, and then it become increased, and then keep on increasing stage, and finally we can see the, okay, cost is reduced to the greater extent. Got my point? This is like a scatter. Okay, so for scatter we have to just give the command like, okay, so I want to give the title, if I want to give the x-axis to be labeled and y-axis to be labeled, everything I can give like this. Okay, so scatter, like a plot, that is the name, okay, plt, okay, dot scatter, and I have to give between the age and price, okay, for this particular data frame, and then I have to give c equal to red. So red color I have to give the dot, and then this is the title to put scatter plot of age versus price, and the x label, okay, that is price euros, and y label, that is age of month, and if I'm giving show function, the graph will be shown. Okay, so this is how I can finish this. Okay, and then coming to the next, I can go for the distribution plot. Okay, if I'm going for the distribution plot means I have to divide, okay, divide the okay, so here I can go for distribution of a numerical variable by dividing the data into intervals. Okay, if I want to make it dividing the data into the intervals, so I can go for distribution plot. Okay, so histogram I am giving for the kilometer. Okay, for the kilometer I am giving. Okay, so here I am just giving on the base of the kilometer, I am just giving it out here. I'm not mentioning any scale or anything else. Okay, just in the histogram, it will make automatically, and it produces the result out of it based upon the kilometer. Okay, and how much it reaches. Okay, and coming to histogram in detail, if I want to make the edge color as white and the color as green, okay, and bins equal to 5. If I'm giving bins equal to 5 means the total number of the kilometer it makes, it will automatically, okay, divided, and it divided into 5 parts. Okay, so 25 means 5,000, 5,000, like that. It may divide into equal scale, and it will give the equation. Okay, so that is how I can also give with the scale. So that's why bins equal to 5. Okay, and then I'm giving a kilometer for that, the same okay, graph, how with the thing. Okay, to know the difference only, I have given the ordinary histogram without any conditions. But here I can give color as green and edge color as white. Okay, and then give the title and X label as kilometer, and then Y label as frequency. All these things are missing here. Okay, if I'm missing here, that also you will get the result, but without having X label and Y label, without having the finite scale, simply it will find out, and it will give the histogram result. But here you can see that 5,000, 10,000, 15,000, like, or okay, like 50,000, 1 lakh, okay, 1 lakh 50,000, 2 lakh, 2 lakh 50,000, like that. The kilometer of the car, okay, it run, and then it gives the analytic result. Got my point? So graph which is make it into equal format with X and Y label and with the title. Got my point? If I want to mention like this, I can give with the, okay, scale, then it will work, right? And then coming to the next is counts. If I'm giving the counts as 979, I myself taking it as 979, 120, and 12, like that, in the form of list. if I am giving, and then I am mentioning the fuel type as petrol, diesel, and CNG, in which I am just taking randomly the number as 979, 120, and 12 for petrol, diesel, and CNG and giving. Okay, and then index arrange len of fuel type. If I'm giving like this means I will get the value based upon this count, and then I am giving length, that is len of fuel type. How many fuel type is there? Three. So according to that, the scale will be set. This is also we can do. Got my point? So using this len function, I can also set the thing directly. In the previous, we have given it as like 5, and then it is equally divided. But here, based upon the len, sometimes we will not know how many categories. For categorical data, we will not know. Okay, but this is a numerical data when we find the maximum and we can give the scale. But for categorical data, it may be many categories for 1 lakh records. If it is there, means we cannot find out the number of categories. So just we can give the len of fuel type. According to that, you just make it means how it will function for petrol, separate thing, for diesel, separate thing, and then for CNG, it will find the separate thing. Okay, according to the fuel type, it will form the different thing. Okay, and then frequency, based upon it, it gives the result. In order to give more understanding, I can add more features into it. So what are all the things it is given here? Index, counts, and then color. That means here I am giving a red, blue, and xenon. That is the three colors I am giving. Red is for the first fuel type, blue is for the second, and xenon is for the third one. And then I am giving the title as well, and I'm giving the X label as fuel type and Y label as frequency, and then show. So here automatically it make it into three types. That is 0, 1, 2. Got it? So this is how it forms the scale based upon the length of the thing. Okay, length of the fuel type. That means three. Okay, so three categories are there. So three, okay, it will be categorized into three types, and then it gives the scale also uniformly as 3. Got it? So this is how I can make it, and for each and every type I can show different colors, and then I can give the frequency, that is the label, and then I can give the title as well. Right? This is about the histogram. Okay, so this is about the histogram. And then coming to the second category, that is data visualization in that is scatter plot. In addition to that, I can give with the grid at the background. Okay, and also I can also give the regression line as well. Got my point? According to the regression line with the scatter plot, so that I am just combining the two. Visualization into one, and I'm asking to plot it. Okay, so that also I can make it. See, for example, style I'm giving dark grid means background you are giving the square, right? So that also can be displayed. That will be easily seeing the scale. Okay, when I'm giving 10,000 means I can point very clearly that which one that hits the 10,000 at which particular year. That and all I can find based upon the square if I am giving at the background. That is dark grid. And then I am giving the regression plot. This is the regression plot I am giving. Okay, so for that, between the age and price. Okay, so the best regression line fit line it gives in this particular thing. And then based upon the age and price, I have to give the what? Scatter. Okay, so when I'm giving the scatter plot also, okay, it will give so regression plus scatter plot. Got my point? So that's why I am getting between the age and price regression line also I received. Okay, and then best regression fit, and also I'm getting the scatter plot. So this is new. You didn't see in the data science. Okay, so this we have added in this particular thing. So please be concentrated in it. Okay, all the other thing you have seen in the previous semester itself. And the next, when we look at about the thing, okay, when I'm giving okay, fit is equal to false. If I am giving equal to false means there will be no fit line. Okay, regression line will not be available. If I'm not giving like this means defaultly it will be like true. Got it? So now without the regression line, only the scatter plot between the age and price will be displayed. Got it? So this is the another category. And then coming to the linear relationship between the variables. Okay, so if I am giving a LM plot, okay, so that is a linear relationship plot. Okay, when I'm giving between the age, price, okay, and okay, so for the fuel type, okay, so between the age and price only, and for the different fuel type, I want to just plot. So that is the time between the age and price only we have seen in the previous. If I based upon the fuel type means I have to give HUE equal to fuel type, HUE, that is HUE equal to fuel type. If I'm giving like this means, and also the color. Okay, so that's why I'm giving palette equal to set one means, so blue, green, and red is one palette. Okay, that is set one. If I'm giving set two means some other colors combination will come and it will be displayed. Got my point? So that is how I can also display. Okay, not only the between the age and price, but also in terms of fuel type. If I want to make now, I can understand that. Okay, the red, okay, which are all the things that comes under petrol, whichever comes under diesel, whichever comes under CNG. So if I want to give legend, that means if I'm giving okay, so legend equal to true, right? So if I'm giving like this means the different colors, what are all the things it will be displayed. If I'm not giving this legend means this will not be displayed, then we will not know which color belongs to which one. So here now I know red belongs to diesel and blue belongs to petrol and this green which belongs to CNG. Okay, because petrol is more because here automatic and manual which is available. Okay, so the maximum number of car is petrol, right? So that's why maximum data points is blue in color, right? And coming to the next, that is a count plot. Okay, so here X equal to fuel type again across the CN, different fuel type like diesel, petrol, and CNG only we are giving. Okay, and then car state. Here, what we are doing is I'm counting. Okay, only in petrol only we have this automatic. In diesel and CNG, there is no automatic. So we can just see how many CNG cars, that is a very few, and then diesel also few, petrol only maximum. That's why even in the scatter plot, we have seen so many points which comes under the petrol only. And under this petrol, again, I have the another type that is automatic. But the automatic features is not available in diesel and CNG. If I want to see this count, I can go for this particular plot. Okay, that is count plot. Okay, count plot. If I give it will count and it will give the beautiful bar graph. Okay, to display the result. And then coming to the box and whiskers plot, as you know, this is also for the numerical variable only. It will do box plot. Okay, so this is the data frame and then price. Across the price alone, I am just displaying it. As you know, this is the like 25% and this is 50%, that is the median value. And this is 75% quartile. Okay, and then these are all the things which is away. The boundary can be call it as like a outliers. Okay, so that is the box plot. Okay, so we can see these are all the outliers which is beyond the bound. Okay, so that is how I can just display. Okay, that is box plot. And then coming to here, box plot, and then X equal to cost data, that is the thing across the fuel type. Okay, and then Y equal to cost data of price. Okay, so here I am giving the fuel type, that is diesel, petrol, and CNG. Each and every type I can just make the box plot. Okay, so that is the next condition. The previous one we have not mentioned the fuel type, so it gives the complete result of the data set. But here across the okay, each and every fuel type I categorize it, and then I have asked to make the box plot. In CNG there is no outlier. In petrol, outlier is available. Diesel, few outliers are available. Got it? So this is how I can make it. And violin plot, which is a combination of both box plot and okay, you can see it's a combination of box and density plot. Okay, so here also we can see three categories. One is diesel and petrol and CNG. This broadness, we can see that how much, okay, it deviates. And then you can see the box plot that shows the 25%, 50 and 75% quartile of the values. Okay, so both, if we want to mention, then we have to go for violin plot. It looks like a violin, right? With the strings. So that's why we are calling it as like violin plot. in which we are having the combination of both box and the broad. Okay, so that is how we are getting the result out of it, right? And then coming to the next, that is a strip plot. Okay, so in here, you can see the different diesel, petrol, and the CNG, the fuel type, and with the price, we are just making it as like a scatter. But here also we can show it as like automatic and okay, automatic and manual. Okay, one we can see the okay. So zero is like manual and one is like the automatic. So that's why in CNG and diesel there is no automatic. Only here we are representing for petrol alone we have the automatic. So price varies okay for the different cars that is plotted. Got it? So that is how we can just show for this strip plot. So X, which is give the fuel type, and Y, which gives the price, and then data, which is the cars data. Okay, that is the data set, right? And then we are having the UI, that is automatic, and then we are giving the Dodge as true. So when we give like this means there is no box or no broad, nothing else, only the count, and it will be displayed it as like a scatter plot, and it will, but the count will be mentioned and it will be clearly visible. Okay, based upon the count or based upon the price of each and every car type that will be displayed. And the next is pair plot. Pair plot means, as I told you, there will be so many columns, attributes which will be there, and different pairs it will be take. Okay, for example, price and another attribute, and age, and compared with the other all the other columns. Okay, and then coming to the kilometer and all the other attributes. Okay, compare with, and HP with all the other attributes. Mid color. So likewise, 10 attributes if it is there means take one attribute and compare with the remaining 9 and gives the result out of it. Okay, so this is called pair plot to show the complete okay attributes how it works and the relationship between the attributes we can find out. Okay, and then coming to the next part is data cleaning. Till now we have seen about some of the initial accessing how the analytics can be done and things like that as the first part. The second part we have seen about how to visualize the data by using the different graphs we have seen, and now we are going for the third part that is called data cleaning. Okay, how the data cleaning can be done. Okay, so here you can see that first reading the file, okay, and then okay, so making all the null values, okay, as NaN, and then copy it into the new data frame, okay, and then we have to find out the sum of the null values. For price, there is no null. Age, there is null. For each and every attribute to find out how many null values I can give is NA function dot sum. If I'm giving like this also, I can find. And also the other method is null. If I'm giving this function also, doing the same process. Okay, either is NA function dot sum also gives the same value. Okay, and then is null dot sum also gives the same value. Each and every column, how many null. Okay, it will be counted and gives the result out of it. Okay, so this is how I can find out the number of null under each attributes. Okay, and the next is I can just describe. Okay, and then I'm describing it. Already we have seen about it. Okay, in the previous okay in the beginning, and then I'm just going for calculating the across the okay along the mean. That means what? I'm giving the data type age and fill in a. That means okay. So and cost. So if wherever if I'm having null, in which I am just filling with the mean value. That is the meaning of it. Got my point? So as I told you, how you are going to replace the null. Okay, data cleaning, how it can be done. Sometimes the query will be asked. Okay, fill with the mean value of it. So average, taking the average of the complete column and taking the value of it only for the numerical value, right? Numerical value average we are taking, and wherever the null comes there it will go and fit in it. Okay, so that is called actually like a fill in it. So how you are going to fill this particular in age, I'm going to fill with the mean value. Got my point? So that is the meaning of it. Okay. So if I'm just putting age, okay, you can see there is no null which is present here. Got my point? Okay, there is no null. If any null which is present means it will be okay converted into a mean value of it. Okay, it will be converted into the mean value of it, and it gives the result out of it. If I want to fill it with the age alone with median, okay, if I want to calculate the median value of it, then I have to just give for the particular age column what is the median value. Got my point? Okay, median value, that means the middle value of all the data, all the records in the particular column age. If I want to mention, I have to give dot median. Then in that age, I'm getting the middle value as 59. Got it? And similarly, I'm getting fill NA of median. That means again the same thing. Like, okay, so I want to replace any null value which is present across the age. There, I'm just have to replace it with median value. That means this 59 have to be filled wherever the null which is there only in age, not in other thing. Okay. So that is how I can do it, right? And the next is data for, that is the data frame dot I location, okay, and then colon comma 5. Okay. So if I'm giving like this means, okay, so here all the 1436 rows and the columns will be displayed. Got it? So only the which particular attribute, fifth attribute alone I have to mention. In the previous thing and all, we have given the attribute, but here I want to just see only the med color. Okay, if I can give like this, comma 5. Okay, colon, comma 5. I location, that is to that particular location in which I have to give the fifth attribute. That is med color alone. I'm just putting it out. Okay. So if I want to mention any the fifth column or sixth column means you can use I location colon comma that which particular attribute I want to display. If I want to have a fuel type and fuel type is in the fourth, then I can give colon comma 4. Only the fuel type attributes will be displayed. Got my point? So that is how I can just mention. Okay. And then if I'm going to give only for the med color, what is the mode? Okay. I can get the value as med color as mode value I get measuring and 0. Got my point? So this is the another way of finding the mode for a particular attributes. Okay. And then filling the any okay med color having null with the mode. Okay. So then I have to give like this. Got my point? So this is how I can fill with mean or fill with median or fill with mode. Okay. So mode means number of occurrence. Frequently, the number of occurrence, how much times it occurs, that we are finding out and we are giving the result out of it. And then if I am giving, okay, so I location, same thing. Okay, the med color which is displayed. And is a name of sum, we have did already. Okay, so it gives, okay, so how many null values which is present. Okay, and then cars data, fuel type, values, count of index 0. Okay, that means across the rows. Okay, across the rows, it is finding the fuel type. Okay, so fuel type of value counts. Okay, if I'm giving, if I want to mention it only the petrol. Okay, so if I want to have it as like which has both, some of the queries sometimes it has like both automatic and okay manual. I can just give it as like okay petrol, we get the result out of it. Okay, and then coming to the next fill NA of again, okay, count, already we did it. Yeah, during the practice time it is repeated. And then skew, this is a most important thing. Okay, skewness we have to find out. Okay, skewness means sometimes in the data frame, okay, sometimes in the data frame like you will have the positive q and sometimes it will be like a negative q. How we can differentiate the positive q? See, for example, if you are having the data set like a employee data set in which the income distribution, if we want to find out, okay, so where the small number of people earn significantly, higher than the majority. Okay, higher than the majority. If that situation means we can say that is the positive skewness. Okay, positive skewness. If it is a negative skewness means the tail is on the left side. That is called negative skewness. For example, age at the retirement, where most retire at a latest age, but only few will retire early. Okay, in the first case we have seen only few people will get high salary, right? And all the others will get low compared to the high, right? So that is the example for the positive skew. And for the negative skew means we can see that only few will get retire at early stage, but most of the people will retire only at the old age only. Got it? So that is the negative skew. Got it? So this is how, based upon the data set which is accumulated, okay, to the tail end, then we can say this is the positive and the negative, or we can say it as like left and right skews. Okay, so that is how for our data set we are getting, and then the age column we are putting it out, and the skewness we are making it as right skew. Okay, so the value is minus 0.08. So the range, it is towards the right, okay, to the maximum. So we are getting minus zero point 0.8 to the right skew. Okay, so that is how we can say, right? Okay, and the next is finding the um, Z score. Okay, that is also one of the question I have given in 1A. So I have just included this code. How to find the Z score? Okay, for that I have to put the formula, that is sigma by x minus mu. Okay, mean and standard deviation. Okay, we have to just put for the particular data set and finding the value of it. Okay, and finding the range between minus 3 and plus 3. Got it? Okay, minus 3 and plus 3. The range is between the plus 3 and minus 3. Okay, then the Z score. Okay, you get, or otherwise it will be considered as the thing. Okay, so that is how we are just finding the Z score as well. Okay, so with this, 1A will be over, and then 1B we will concentrate much on the data cleaning part, that we will see it in the 1B, right? So that we will see later, right? Thank you.